All right, let's remember we're talking about right triangles here. And when we have the angle located here, the side across from it is the opposite side. The side that it's sitting on is the adjacent. The hypotenuse in a right triangle never can be changed. It is always across from the right angle, okay? So yesterday's lesson, we worked on that. So let's look at it again very quickly. If theta is right here, over here is going to be your opposite side. Right here is going to be your adjacent. And across from the right angle is always the hypotenuse. So in this triangle, here's the right angle. So across from it is my hypotenuse, the longest leg. Here is theta. Across from it will be opposite side. And that it rests on is going to be its adjacent side. Again, just doing a quick review. We give each of them names. We have the sine, opposite over hypotenuse. Cosine is adjacent divided by hypotenuse. And the tangent is the ratio of the opposite divided by adjacent. So we've created all these different ratios, opposite over hypotenuse. And then we have a relationship of adjacent over hypotenuse. And finally, a relationship between the opposite and the adjacent side, those ratios. We remember with the expression, some old hippie caught another hippie tripping on acid. So here is some old hippie caught another hippie tripping on acid. We should know those at this point. We did them back in geometry. So let's look at this triangle and see what we know to be true. This is what we want to learn today. Well, I see an angle. It doesn't give it to me like it normally does, but it does give me the two side measurements. And if right here's theta, this guy over here is my opposite side, and the 15 is the hypotenuse. Well, let's think for a second. Some old hippie caught another hippie tripping on acid. Who has opposite and hypotenuse? That's the sine. So here's what I know. I know the sine of whatever that angle is equal to opposite, which is 6, divided by 15. I know the sine of something is equal to 6/15. Now I could change 6/15 to a decimal and then go searching. But the question is, back in my day, that's what we had to do. We had to look in the back of a book and look up the value and find it. And then there the angle is 23.762. But today we have calculators much nicer than what I had. So I need a way of undoing this sine. I want to get rid of him. How can you get rid of him? Well, if you come in and you take the inverse sine, called the ArcSine or the inverse sine, if I do that, it's going to get rid of him and leave just theta. But if I took the inverse sine on that side, I got to do it on this side. So theta is equal to what's called the inverse sine or ArcSine of 6/15. Well, if I go to my calculator, let's go to a calculator here. Remember, you need to make sure this is in degree mode always. And notice there's this button IN, okay? Right here, INV. Okay, that's natural log. INV is right here. If I hit that, notice it turns this to inverse sine, inverse cosine, inverse tangent. So I hit inverse sine, which notice it says ArcSine. The numbers we had 6/15. So I'm just going to go 6 divided by 15. Has in parentheses, I hit equals, and it says, hey, that's 23.57 is that angle measurement. So about 23, we'll say 23.6. So back here, we'll say, hey, theta is approximately 23.6 degrees. And that's what it's going to be if you have that being 6 and that side being 15. We come here, we're like, hey, who do we have? I have the opposite, and I have this guy here, the adjacent. Well, that's going to be the tangent. Tangent is opposite over adjacent. So the tangent of theta is the opposite, 15, over the adjacent, 24. So now, how am I going to get rid of tangent? I'm going to take the inverse tangent of both sides. This is actually very easy to do. So theta is approximate. I go to my calculator, type in the inverse tangent, 15/24, and I'll just tell you I got 32.0 degrees when I did it earlier. Let's look at one more little bit. How would I solve this guy? He wants to figure out what theta is. 3 plus 4 times whatever the sine of theta is equals 5. How do I do it? Solve it like it said 4 times x. Well, the first thing you do is you'd subtract the 3 and you'd say, hey, 4 times x, the unknown, equals 2. Now, how would you get the sine of theta or the unknown by itself? I'd divide by 4. So the sine of theta is equal to 2/4, or really a half. What am I going to do to now get theta by itself? Because that's the piece we're trying to figure out. I'm going to take the inverse sine of both sides. Believe it or not, it's going to give you a perfect 30 degrees. Hopefully all this makes sense and it rings a bell because you have seen this before in geometry.